This is a production of Cornell University.
Go.
How many different forms of nitrogen can plants take up?
Basically the two forms, ammonium, this one, and the nitrate. Those are the two forms that plants can take up. We, as biological organisms, can't. We need to bring it in this way. It needs to already be in that form. We, as different trophic level than plants. Plants are biological organisms too. Okay? All right. Now, that brings us to questions about the cycle itself and fertility. Okay? When you talk about a cycle often implies that it's completely closed. Okay? There's not going to be any losses to the system. The reality is that the nitrogen cycle isn't truly a cycle in a dafic sense, it's a cycle in a global sense. Okay? There are leaks in this cycle locally. I have leaching, I have harvesting, I have erosion. Those are leaks, and every one of those leaks are going to take the nitrogen out of the cycle. So it's not truly a cycle in a local sense, but it is a cycle in a global sense. Okay, I can have erosion, which takes that nitrogen away. I can have harvesting, which takes the biomass. I can have leaching, which basically takes the nitrates out. I can have denitrification, which takes that nitrate and converts it to N2 gas, which then could be gassed out of the system. We can also have potentially a burning event. If I have a burning event, I'm basically going to be burning up all of this stuff and this stuff, which basically means it's going to volatilize out of the system. So it's another leak. Okay? And these leaks, when we think about it from a management sense, the only tools that we have are basically increasing nitrogen fertilization or increasing biological fixation. Now, we do, in fact, have some other controls. We can minimize leaching. We can minimize harvesting or sort of maximizing a harvest but remaining all the residual behind. We can reduce erosion. So there are some other controls, but when it talks about actually getting nitrogen into the system, these are the only two things that we can do. We can add fertilizer in some form, whether it's an organic form or an inorganic form, or we can increase biological nitrogen fixation. It's the only ways we can get nitrogen into the cycle. We can reduce the loss of it, but those are our only tools to bring it into the system. Now, if we start talking about soil erosion, basically this is a map showing Africa to Asia. The brighter the color, more erosion is occurring. Okay? Now, if you look at where these brighter colors are, in a sense, we're looking at more agriculturally centric areas, sort of India, Malaysia, and China. Lots and lots of agriculture in there. But we're also looking at some climatic effects here. Okay? If we did this at the Dust Bowl prior in the United States, back in the 20s and 30s, we would have something that looked like this as well. Other potential losses is harvesting. Okay? Now, this is, the white part is basically the residual, the black part is basically the material that we actually harvest. Okay? And if you look at this, you can look at the different types of crops and the different responses from harvesting versus what's being left behind. So in theory, anything that's white can be left behind and be added back as organic matter, soil organic matter, back into the system. And as soil organic matter, it's got the amine groups attached to the organic material. So the nitrogen isn't leaving the system. So anything that you can do to bring this component down and concentrate your harvest on just the things that you need will increase, or reduce, I should say, reduce the nitrogen loss from that system. Does that make sense to everybody? Okay, if I start taking corn stubble away and things like that, potentially I'm taking that nitrogen away. Now, theoretically, I could be feeding that corn stubble to my cows and then bringing the manure back onto the field. In a sense, I can sort of increase this by still harvesting in this pattern, but then bringing that material back to the farm. Okay? That would be, in a sense, organic matter fertilization. Okay? But it's based on what's going on here, harvest-wise. So where are these leaches? We talked about this when we did the cycle, but basically we're looking at the gases, the ammonium gas, the nitrate and nitrate, as well as the N2 gas from denitrification. Those are your leaks that are in the cycle. Okay? So How do we feel about this? We're right back to that very complex cycle. But in a sense, we've talked about everything that's here. So let's walk through this cycle one more time. Here's our plant tissue. Biomass, whether that biomass gets into the soil through harvesting and eating, that biomass is going to get to the soil. This material is then going to be synthesized by microbial populations, soil organic material, and we're going to basically see ammonification or mineralization. Ammonia is basically going to be going through nitrite and nitrate. Okay? This can be lost through the system through gas, but this also can be taken up by the plant. This can be lost from the system as leaching, but it also can be taken up by the plant. Okay? This we can augment, and this we can augment through fertilizer, modifying this cycle, reducing the leaks or increasing the nitrogen in that localized cycle. Do we feel comfortable with this? All right? All right, guys, be free.
This has been a production of Cornell University, on the web at cornell.edu.